Hello, I'm Jodi and I'm here to present to you my final year project, Query and Visualization of Expert Network. My supervisor is Prof. Tanahui. So what are expert networks? Expert networks are networks that consist of experts from a specific domain. So by visualizing expert networks, one can study the connections and characteristics that are shared between experts. Expert networks for this final year project are focused on professors from the School of Computer Science and Engineering of Nanyang Technological University. This final year project aims to build an interactive front-end application capable of visualizing the Professor Expert Network. The application will be called Semi-Expert Visualizer. SEMI stands for Semantic Associative Memory Model for Identifying Experts. The backend application was built using Node.js. The current professor dataset is stored in a flat file. The backend system will read the file and create a graph that will be sent over to the Semi-Expert Visualizer. The front-end application was built using React. The front-end application is interactive and includes features that will make the expert network easily navigable and explorable. The Semi-Expert Visualizer has two separate visualizations. The wall map will show the university's location on the wall map. The network graph will be related to the professor. The current result is based upon searching Nanyang Technological University in the control panel. The current result shows all the professors who have studied at Nanyang Technological University. As you can see, both the wall map and the network graph are easily zoomable and draggable. Now I will be discussing the features of Semi-Expert Visualizer. If you search Tanahui in the control panel, all of the characteristics of Prof. Tanahui can be seen. Prof. Tanahui has studied at the National University of Singapore and Boston University. All of the funding bodies where he has received fundings from are purple. His research interests are green, and the research group that he belongs to is blue. Searching Boston University in this field will show you any professor who has studied at Boston University. Searching AI in this field will show you research interests that's related to AI and the professor who have those as the research interests. Searching computational intelligence in this field will show you any professors who belong to the computational intelligence research group. Searching DSO in this field will show you the professors who have received fundings from the DSO. Searching Singapore in this field will show you the universities in Singapore and also the professors who have studied in those universities. You can also change the degree of association to expand or contract the graph. The nodes that correspond to the search results will be classified as primary nodes. The nodes that are 1 degree away from the primary node will be called the secondary node. If you change the degree of association to 2, nodes that are 2 degrees away from the primary node will be shown, and they will be classified as the tertiary node. Primary nodes will be the largest node, secondary nodes will be the medium node, and the tertiary nodes will be the smallest node. You can change the query operator too. If there are two or more inputs, the search results will be according to the query operator. If the query operator is OR, and you search for DSO and Boston University together, DSO and Boston University will be the primary nodes, and the professors connected to those nodes will be shown. If the query operator is AND, you get professors who have studied in Boston University and have received fundings from DSO. The professors that are returned will be the primary nodes because we want to highlight the nodes that share the same characteristics as the inputs that has been entered. In this case, only Prof. Zanawi has studied at Boston University and received funding from DSO, so only him will be shown. You can show or hide nodes related to each of these buttons. Clicking on this button will hide all the nodes related to funding bodies, and clicking on it again will make them reappear. Clicking on this button will hide all the nodes related to research interests. Clicking on it again will make them reappear. Clicking on this button will hide all the nodes related to research groups, and clicking on it again will make them reappear. Clicking on this button will hide the wall map, and clicking on it again will make it reappear. You can show or hide primary nodes as well. Hovering over this button will show you all the primary nodes. You can either toggle them on or off to show or hide them. You can draw a circle to show all the professors who have studied in universities that lie within the drawn circle. You can explore the network graph easily. You can hover over the node to show only the nodes that are connected to the node being hovered. Clicking on them will make them the primary node. This is true for nodes that are on the network graph and the wall map. There are tooltips as well to help the user use the semi-expert visualizer. This feature will definitely help reduce the learning curve of using the semi-expert visualizer. The current version of semi-expert visualizer is interactive and easily extendable. More work is needed to visualize more kinds of expert networks.